Hi guys, welcome to my channel. Today we are going to see about armature reaction in DC machine. Okay, let's get into the topic. So what is armature reaction? It's a interaction of main field flux and armature flux so that there will be a distortion in the main field flux. That behavior of that flux is known as armature reaction. Here main field flux is produced in stator and armature flux which is produced around rotor. So here this pole magnet is a main field magnet, pole magnet, and this one is known as armature and armature conductor. This is a brush, and these brushes are placed in a MNA axis. MNA means it's a magnetic neutral axis. In this axis there is no EMF will get induced over here in the armature conductor, and GNA is geometric neutral axis. The field flux is perpendicular to this axis. To understand the behavior of magnetic flux, we shall see three cases of armature reaction. So the first one, when no load is connected to DC machine, at this condition no current will get flow through the armature conductor. So when current is not flowing, the magnetic flux also doesn't create around this armature. The main field flux with respect to polar axis will get distributed symmetrically in armature conductor. Here the polar axis is a central axis between north and south pole. In this condition, the geometrical neutral axis and magnetic neutral axis will be in same position. So let's see next condition. Here the current is flowing through the armature conductor and no current is flowing through this field coil. Here don't consider this as a pole magnet. Here we can consider this as field coil, and this one is not producing any flux. So here in this case the current flowing through this armature conductor and no current is flowing through this field coil. So the direction of current in armature conductor is represented by X and dot. Here X means the current flowing inward and dot means the current flowing outward. Due to current in this armature conductor, the magnetic flux produced around this. So when current flowing inward, the magnetic flux direction will be clockwise, and when current flowing outward, the current flux direction will be anti-clockwise. The direction of armature current is determined by Fleming right hand rule and the magnetic flux produced due to it and its direction, and this magnetic flux direction is determined by Maxwell right hand thumb rule. Okay, let's see the next condition. So here the current is flowing through both main field, which is stator and also in armature conductor. At this condition the flux will get produced on both, as main field flux also produces and the flux is produced around this armature also. And in this condition DC machine is connected to the load. So now both field will get interact each other. As you can see, this is a main field flux and this is armature field flux. This both will get interact each other. Now this armature flux will opposes the main field's magnetic flux and creates a distortion, because here magnetic flux is flowing from north to south for the main field flux, but armature flux opposes it upward at some point and downward at some point. As you can see, this armature flux is moving clockwise upward, so here the magnetic flux will get distorted up, and here you can see the arrow mark is downside, so here it will distort it down. And same as well as here, it will distort down, and here it will distort up due to this magnetic flux straight line, which is go as sinusoidal wave like this. Due to this, the DC emission efficiency will get reduced. So as you can see, now the main field flux will be like this. Now this reaction of main field flux due to armature flux is known as armature reaction, and in this condition, due to this condition, the magnetic neutral axis will get shifted around the where resultant flux is more. So now the neutral axis is shifted over here. So when the neutral axis is shifted here, so it will create a spark on the brush and it will damage brushes also. Okay, let's see the effect due to armature reaction. The main field flux will get distorted due to armature flux. As you see, I have shown in previous diagram, it will be like a sinusoidal wave. So armature flux is produced around this is clockwise and here anti-clockwise. So here the resultant flux moves upward more. So here the flux is distorted upward, and here it is downward, so it is gone down. Like this, it will get distorted. In case of DC generator, the magnetic neutral axis is shifted in direction of resultant flux, and same opposite in case of motor, and there won't be proper commutation take place. As you know, the magnetic neutral axis has been shifted, so due to that the commutation can't be able to take proper and efficiency will be reduced. Okay, thank you guys. I hope you understood the topic. Let's see in next video. Thank you.